Okay. So this is me, and we're fortunate enough to have a lot of very, very good talks that were proposed for this NANOG in this area. We were calling it BGP Dynamics track, but there are also a lot of these talks are talking about trending and operational issues. So this is sort of my own working title for this session. Now this is also a track which isn't exactly a panel, but it's something like a panel. So we'll see how this goes. So my agenda for this track is, first I want to tell you a little bit about the logistics, and then I want to, since all of these talks were, or most of these talks were based on a lot of data collection, I want to give you a little bit of an update on where we're at with that. And then I want to just talk to you a little bit about an introduction to what these talks are going to be about, and then do the talks. And if you want to see these slides, there's some slightly earlier version of them there on that URL. Okay, so the logistics of this. First off, we have a few discontinuities in our schedule, in our agenda, and they're sort of the air and open mic. If you notice on the updated agenda is sort of in the middle, which is okay. And then we have some breaks and lunch and so forth. So what I would like to do is, please, let's hold the questions to the end of all the talks, but please send them to questions@nanog.org and put BGP panel and some tag about your question. It really doesn't matter what you put there. And Lucy will collect them all up, and then at the end, hopefully we'll have some time. We'll have some time, won't we, at the end? Okay. And the only other thing I want to say about the updated agenda is that I think Susan did a really wonderful job of moving things around so we could have the maximum amount of time. Because I think these are really good talks on a good topic. So those are the logistics. Okay, so let's go on with this BGP data sources. I happen to be involved in collecting some data, so I know a little bit about this one. The first one I wanted to talk about was the routing information project, which is, I don't know how many of you have looked at this, but this is a substantial project which is capturing quite a bit of data. And what they're using is Zebra BGPD. And the real nice thing about this is that the Zebra BGPD can archive, has its own internal archiving mechanism. I don't know if anybody's looked at this, but it does MRT format archiving of the RIB and updates. And MRT, that's the URL if you're interested in MRT. So that's one of the major sources, and I think Cengiz's talk and maybe a couple of the others use data that they've gotten out of this project. And I have my own, which is route views, and this thing is capturing show IP BGP format, Cisco format, at 2-hour intervals, and we have a nice script that Sean wrote to do it. Earlier on, the archive of that data is on this thing called archive.routeviews.org. And a lot of people seem to be archiving it themselves. You can just get it there if you want it. And there was an earlier archive predating what I have that Hans Werner had on mode.nliner.net. Bill is archiving some of this data as well on pch.net. I don't know the exact URL. He might want to talk about that when he comes up a little later. Okay. There's any number of looking glasses out there. There's a good list on this isn't really archival, but there are a lot of looking glasses out there that people use to find this data. And then finally, there's quite a few private listeners and private archives that people are running. So the amount of data we have is really, on the routing system, it's really growing, and it's really pretty impressive if you look at what some of these projects have done. I want to talk a little bit about route views because that's the one I know about, a little bit about the history of it and what happened last month or whenever that was that I broke it so badly. So the history of this thing is, about 1995 I was building some network stuff in Oregon, and I really wanted to see, I needed a way of looking at how other providers were seeing my routes. And so the whole route views project really started life as just an operational tool for me, my personal thing. And as I said, I needed a way to see how people were looking at my routes. And there were no looking glasses. That was something that was off in the future still. I think Ed Kern had one up. It was nitrous 10 minutes left. nitrous.digex.org, and but not much. So Randy Bush gave me a eBGP multi-hop session from Mae West, and I think it was on like a Cisco 2500 at the time. You can believe that. So people started asking me, can I use it? And yeah, and I, didn't have a password on it, and I did really stupid things like didn't turn off Telnet, and all of these things. And okay, so we learned our lessons. And then at some point, I think it was Casey who realized that there was like, after we'd have all these views and there's a couple of hundred megs of paths in there, she realized that there is sort of a data source. And when this picture came out, I started getting a lot more people asking me if they could contribute views. So I haven't stopped acquiring them, and I think that thing has become more useful over time. So this is the current situation. Thanks to Cisco, they donated this box because it wouldn't run on anything smaller anymore. I happen to be running 19S on it right now. It has about 63 peers. That kind of fluctuates a little bit. There's about 700,000 paths in it, a couple hundred megs of RIB, and it takes about 4,000 connections a day of people just looking at it for either archival or operational use. And if we look at the archive, we see that there's about 50 downloads. I don't know what people are doing with this data, but they're certainly getting it. So that's the state of the world as we sit right now. So I had a few issues. I just want to mention a few issues if you plan on doing something like this. First off, if you have, we went through a whole thing about acceptable use, but of the data. But what we wound up doing is just dropping that. Obviously, processor and memory scaling in this box is a problem because it's taking a lot of updates. It's taking a lot. The data export thing is a problem. We had a lot of trouble with just getting the show IP BGP out of it because basically there was so much data in it that the TCP stack on the other side kept dying. And fortunately, Sean put some effort into kind of working around that for us. Peers come and go. People call me up and say, hey, you have 15 dead peers on this thing, or so you have to kind of watch that and resolve them. And going along with that, since actually people aren't customers, you never find out that the peer on the other end had moved or something until somebody calls you and said, hey, there's dead peers on this thing. Oh, NLRI support, people are wanting things like IPv6, multicast we have, stuff like that. Oh, and then of course there's all these security issues. Can you Telnet away from the thing, and can you SSH to it? Can people read your config or see where you TFTP'd the config from? And people, I used to have a boot system lying in it, and people could see where I TFTP'd it from, and then they'd go and TFTP it, the config, not knowing that the thing's on the web anyway. So, what to do with this thing? Well, it seems to be a pretty useful operational tool. And as many of you know, what I wanted to do was I wanted to migrate from the Cisco hardware to BGP, Zebra BGPD for a bunch of different reasons. The main one was we're trying to unify the data export format that we have for all these things, so researchers who build tools that work against MRT will have that. The second thing is that the operational end of it, this was my theory by the way, the operational end of it would still be okay, because if you could get the Zebra BGPD to listen on port 23, then you can just Telnet to it, and it looks a little bit like a Cisco. It doesn't have these things which people mentioned, and vertical bar is probably a big one when you have that much RIB. And obviously it's less expensive hardware. So Joel built me this box, and this thing, this is a Joel thing, he loves to do this. So I built this PC, which I thought was a pretty big PC and would be good. And we were running Linux 4.1, and I was running CVS Zebra BGPD, and so I just thought, well, I'll just cut it over. Okay. And what went wrong is, well, BGPD couldn't start all the peers, and there were some issues with the scanner thread. The BGP CLI thread was really slow, and people called me up and said, hey, what happened to it? It's unusable. So what to do? Work with the Zebra implementers. Look for other implementations. This one I wanted to ask about. We could just replicate it, leave the other one there, and do this for data collection. And there's one out there right now. It's got about 20 peers on it, thankfully, to people in this community, and you can tell that to them. Look at it. Okay, so that's the history of how we're getting all that data. Okay. So here's, okay, so this is really what we're here about. And this is sort of the picture that, you know, the classic Jeff Houston picture. And this is what we're dealing with. And so what does this curve mean? Well, if you look at a closer look at that one, and sorry about this image, I had to shrink it because of non-deterministic behavior of magic point, I guess. But basically, what is the real shape of that curve? That's what we're asking. And if it is exponential, what can we do about it? So here's the challenge I want to make to all of you folks. So during these talks, think a little bit about the following questions. And maybe, I know you'll all have a lot of questions, but maybe you can think about these because I'm interested in these myself. So first off, is our methodology a sound thing? Because we get different views from different points in the topology, right? So what is our methodology for doing data collection and analysis? And you can look on these URLs for some interesting stuff. And what approaches should we be taking in the research and data analysis community? And what results would be useful for us operationally? These are the kind of things that we'd really like to know. When we start talking about RIB and FIB growth rates, what is the current growth rate? And what does it mean? Like, is it exponential? Is it linear? Something else? And what are the drivers? Is it more specifics, multi-homing? That seems to be a popular thing. Is it something else? Are there actually problems that we're dealing with related to this? Like, are we out of RP or line card memory? And if this is true, what tools do we have available to us? Related to this is the AS interconnection mesh growing. And how about the AS number burn rate? This says something about what the economy is doing. What about the dynamic properties? Is the dynamic nature, churn rate of the routing table growing? Where does it come from? Do we expect increased churn if the fraction of longer prefix is growing? And if so, is it the case that more specifics churn more? And what does that mean to us? So here's a little bit of a hint. But basically, the /24s are much higher, and you can look on my slides on that, whatever that URL is, and you can read that. So again, are there observable problems related to that? That is there not enough CPU? Are we using too much protocol bandwidth? And if that's true, again, what tools do we have to deal with this? If it's not an operational problem, will it become one and when? Okay, so there's some, I mean, these are sort of the main focus of our thinking in a lot of ways. There's some other topics to consider, and basically this is maybe a question about the whole thing, is how long will the current routing system last? Will Moore's Law rescue us eventually? What about address space coverage? This is a big issue. How many prefixes do we actually need to cover the entire space? Because that would lead us to some conclusions about how we can aggregate. How about configuration issues? What's the effect of misconfiguration on policy, and what's the effect of multiple origin AS? How does it arise even? What about the effect of DOS attacks? Like, we know that Code Red and Nimda were attacks on end systems, but were they really? Okay, so now I'm down to like 15 seconds. Here's the agenda that Susan so skillfully built for us. Randy's talk will be given by Bill. Thank you, Bill. Then we're going to have a break, and then this is the discontinuity here. We're going to have the Aaron open session. Actually, in a strange way, these are related. Then there's a very interesting talk on routing instability during Code Red and Nimda lunchtime. And then Bob Mallon, I think it's pronounced, is going to give Craig and Abba's talk, which I actually haven't seen that, so I'm interested to see that one. And then we have a couple of talks on misconfiguration, and then a really interesting talk from Cengiz on how well-CIDR is functioning. I think I'm down to 0. Is that correct? So let's send questions to Lucy, and keep them in mind, and we'll do questions at the end.
We can relate. We have a few minutes extra at the end. Well, okay, I don't want to cut you short.
Randy's slides. Yeah, I can actually Should I put all these slides up on the web so these people can get them?
Yeah, as well.
Should I just,
You are.
oh, they're up? Okay. Are they on the back? No, all the ones like Randy's slides here.
Hi. Twice in a row. Worked. All right. Hi, I'm Randy Bush. Let's see. And somewhere. Uh-oh. There we go. Yes, that's my first PC. Isn't it cute? All right. So you guys have probably, many of you, seen these slides before. This is the infamous up and to the right curve showing the imminent demise of the internet, gifts at 11, etc. The Randy perspective on this is that the sky is falling, but not too fast, and proper engineering will hold it up. So he was getting frustrated by the rumor mongering both among the IAB and among telco folks. CircuitZilla being his name for the telco rumor back channel or whatever. And he wanted to spread some counter disinformation or something. This is the same slide you saw before. Stolen from Jeff Houston, as Dave's copy of the slide was stolen from Jeff Houston. So we had the Tomain meeting at the last IETF, where there was a lot of talk about this stuff, and these slides are based primarily on work by Jennifer Exford, which Randy was presenting there. The summary. Simple world is you have a customer, points default at the ISP. The ISP has nice aggregated space, points it into the rest of the internet as a nice big block. Unfortunately, what's actually happening is customer multi-homes, because the circuits between them and the ISP aren't quite reliable enough because they're not paying enough money, and so instead they pay half as much money to twice as many ISPs. The ISPs now have to break out the announcement as a /24. The second ISP, that's all they've got, right? They advertise 24 through. The first ISP, in order to keep all the traffic from coming in exclusively to the second ISP, because it's more specific, they have to pass the /24 through also. So now instead of one route, we have 3, and that is the cost. So these are the small multi-homers. This is, as Dave was saying, a lot of folks with little /24s. The /24s are the smallest net block that will be commonly listened to. Therefore, that's what people ship out there. It's these little guys who are sort of least stable. They aren't typically nailing down some cover route, so they're the ones flapping around a lot. The problem is getting worse, and we need some time to come up with an engineering solution. The engineering solution probably being some new routing decision-making algorithm or some new way of passing policy around that doesn't require really remote locations to pay attention to your policy if you don't care whether they pay attention to your policy, because you're looking for a local effect, not a remote effect. So the method that Randy and Jeff and quite a few people have been looking at is just having local propagation of the policy people are trying to enforce, right? If people are trying to get a load balancing between two circuits, just pass that information on to the neighbors, never pass it across a peering connection, only across a transit connection. That is, if you want somebody to listen to a policy, you pay them to listen to it. When the money stops, the listening stops. So here's the old RIPE allocation boundaries and what the smallest blocks that were allocated out of each were. That's what Randy is suggesting people filter on. Here is the number of prefixes viewed looking at AT&T from a RIPE looking glass. It's kind of hard to see. Oh, sorry, it's extremely hard to see. Let me see if the cursor helps. Okay, so line along here, let's see, tops out at 70,000 prefixes if you only look at stuff in the... Dave, do you remember? We figured this out yesterday. Now I'm being clueless up here. Okay. The 24th... Sorry.
That's okay. 20, no, these are the 24th of the two sometimes.
Yeah, okay. So, looking at the A space only, okay. Look at the A space only, you're down here. If you add in the B space, you've got another line here, tops out at 85,000. This is looking at the last year over time. C space, you really can't see, it's in between there. And if you add in all the /24s that are not historical Cs, you wind up with this, 100,000 routes are a little over right now. So again, that's WorldNet unfiltered from RIPE. Okay, this is percent growth in the last year. So again, it's the /24s that have grown most, 20% growth. Everybody else is down here in the 10 to 15% growth. And this is how much of the space is not covered by a larger prefix. That is, how many of the blocks out there that are visible are not also within a shorter prefix that is also visible. And the C's top out here at about, says here 0.18%. That's not very much. The point of this basically being, if you throw away that 0.18% by accident, you're not going to get too many complaints, I guess. Okay, this is WorldNet at route views. This is basically exactly the same set of slides as we just saw from RIPE, but looking in the route views looking glass instead of the RIPE looking glass, topping out at 90,000 instead of 100,000 or 101. I'm sorry. I had it upside down before. The 70,000 before, 65 on this view is the C's. You add in the B's, you get up to 75. You add in the A's, you get up to 80. It makes a lot more sense. Sorry, we had it upside down. Okay, same thing with growth. Most of the growth has been in the /24s. Below that, we've got growth in /A/B, or sorry, the old A, B, and C space, which, whoa, okay, this is a lot different than what RIPE was seeing. So if you remember on the RIPE slide, we saw about 20% growth Oh, okay, in 1 year, here we've got since 98, we've got 3 years, well, let's see, 10, 1, 0, 0. Okay, yeah, so 3 years, near doubling over 3 years in the C space, or sorry, the /24 space. This is, again, what portion is uncovered, and again, we've got a really low percentage. There has been growth over time, and the growth over, oh man, it's quite hard to see. Okay, basically, there's a diagonal line which starts here and goes like so. That's the uncovered /24s, or uncovered Cs. Everything else is just kind of meandering along flat, but there's a diagonal line across here, which is the multi-home, the little /24s in the multi-homing. But again, the total is not very bad, about 0.14%, which is disposable if you look at it that way. Okay, so here's Cable and Wireless's view at route views. Again, seeing about the same thing, topping out at about 90,000 routes. Percent growth, about a doubling over 3 years again. And almost the same thing here. There's a kind of, slight blip, but then down again in the A space. The Bs are a little higher, but again, very mild growth. The Cs in this one are very low, and then pick up at the beginning of 99 and just head straight on up to about, again, 0.14%. Sprint, seeing the same thing. Again, here picking up about October of 98 here and heading up to, again, about 0.14%. So, everybody's trying to predict when exactly the internet is going to collapse. If we look at all of the V4 space being allocated and all of it being advertised as on average /20s, we would have 1 million routes. If we look at the allocation rate, not the announcement rate, but the allocation rate, which is faster, we get to 2010 and a little while and 1 million prefixes. That's 3 doublings in 9 years. That's well under Moore's law. And then we'd have no problem because we'd be at the end of space, of course. So there's the actual allocation rate, which is not linear. We are getting a little bit more mellow here in the last few years. The beginning of that big growth is 98, and it starts mellowing out again about, 88, and it starts mellowing out again about 94. So fairly smooth since then. If we look at the allocations, linear fit, that takes us out to 2026, which really doesn't look too bad. Again, that was Scott Marcus's slide from London. Okay, IPv6 does not solve the problem. IPv6 makes the problem worse because it gives us more address space to break up into little announcements in multi-home. As we had the previous demise of the internet due to running out of numbers thing, Randy doesn't think this one is going to be so bad either. So what we're looking for is filtering to keep from hearing things that are going to cause you problems. BGP mild enhancements to keep them from being propagated in the first place. But we have to do the work. We have to sit around in the IETF and define what we're going to do, and go out and implement it and deploy it. And we have to start now. 2010 is a ways away, but doesn't mean we can slack in the meantime. Whoops. Don't come to the Tomaine BOF a few months ago. Phil there, tell your friends to Phil there, and there are the sources for the papers. Thank you.
I just want to, I want to get a couple of announcements here. First off, the copies of these talks that I have that I read before the session, I just put them there, and Susan, I sent you this email so you can get them. If you want any of these. The other thing, it just was brought to my attention by Steve Huter that Randy's fine. The reason he's not here is that he's representing us in Michigan today. So, in case anybody's wondering.